Hello students, here I am going to discuss one of the important communication systems question which is given in GATE 2019, and this question is about finding the probability of error. If you read the question here, a random variable x takes values -1 and +1 with probabilities 0.2 and 0.8 respectively. Fine. It is transmitted across a channel which adds noise n so that the random variable at the channel output is y, and that y is given as x plus n. The noise n is independent of x and is uniformly distributed over the interval -2, 2. The receiver makes a decision. Okay, the output of the receiver here he mentioned as x cap, that is -1 if y less than or equals to theta, and that is +1 if y greater than theta, where the threshold theta can be any value between -1 and 1 and is chosen so as to minimize the probability of error. So this question is all about minimizing the probability of error. The minimum probability of error rounded up to 1 decimal place is how much? We have to find out. Yes, here random variable x, okay, so two possible values for it, -1 and +1, and this random variable x is transmitted through channel, and in transmission process this random variable x is added with some noise. That noise is denoted as capital N. The output of the channel here is y, and that y is equal to x plus n. Now you can understand that this output of the channel is given to a decision making device. Simply you can use threshold comparator also. Yes, in the last stage of the receiver, a threshold comparator will be there, or you can call that as a decision making device. And the another input to this will be here, he mentioned in the question theta, but generally we denote that with V threshold, that theta. We are very much comfortable with the notation V threshold. Okay. Now he mentioned like if y greater than or equals to y less than or equals to, yes, this output denoted with x cap, that is +1. So if y greater than theta or y greater than V threshold. So I'm using the notation V threshold, and it will be equals to -1 if y less than or equals to V threshold. And in the question it is mentioned that this theta, I mean to say V threshold, is chosen to minimize the probability of error. And what that minimum probability of error we are going to get, okay, is what we have to find here. And it is clearly given in the question, this noise n is uniformly distributed in the interval -2 and 2. So if you see the density function of n, yes, with respect to n, small n specifies the range of voltages possible for this random variable n, capital N. The name of the random variable is capital N, and the values possible for this capital N I am denoting with small n here, and this is uniformly distributed in the interval -2 and 2. Uniformly distributed means density function is constant. Density function, this is density function of capital N. It is uniformly distributed in -2 and 2 means this n can be any value between -2 volts and 2 volts is what you have to understand. And what the height will be here is the total area under density function should be 1. So here it is a rectangle, the width is 4, the height of course will be 1/4 is going to be. Yes. Now first we have to find what this V threshold should be so that probability of error we get minimum. That V threshold we have to find out. and that V threshold is called as optimum V threshold. How to understand optimum V threshold? The V threshold for which probability error we get minimum. That is optimum V threshold. So let's find that optimum V threshold. And with that optimum V threshold, yes, we have to find probability of error, and that will be minimum probability error for us. Okay, yes. So let's find optimum V threshold. And yes, it is given in the question that the probability of, yes, x is equals to -1 is how much is given? Yes, in the question it is given x takes the values of -1 and +1 with probabilities of 0.2 and 0.8 respectively. So x is equals to -1 is 0.2 and x is equals to +1 is 0.8. Because probabilities are different here, to find the optimum V threshold, we have to use map theorem is what we have to use. Okay, so what that map theorem is, yes. So probability of x equals to -1. Okay, what is the probability of -1 to be transmitted multiplied with, so what is the input of the decision making device here? Y. So based on this y value only, we make decisions in favor of the +1 and -1 based on the y value only. So we have to see here, yeah. So what is the density function of y when -1 transmitted? Equals to, what is the probability of 1 to be transmitted from the source? Okay, multiplied with, what is the density function of y when +1 is transmitted? Okay, p minus 1 fy by minus fy upon -1 equals to p plus 1 fy upon +1. And for which y value this equality holds good, that y will be optimum V threshold to us. So here, for which y value this equality holds good, that y will be optimum V threshold to us. So first we need, what is the density function of y when -1 transmitted and density function of y when +1 transmitted, we have to find out. Yes, so here in transmission of -1, okay, I'm writing in transmission of -1, what y will be equals to? Is in transmission of -1 from the source, y will be equals to -1 plus n, and in transmission of +1, y will be equals to +1 plus n. Now, yes, let's see what is the density function of y when -1 transmitted. Yes. With respect to y. Now I need the density function of y when -1 transmitted. In the random variable n having uniform density function, if you add some constant to a random variable, the basic nature of density function remains unchanged. So here y here also will have uniform density function only. Or even you can understand this. If you add some constant to a random variable, simply the density function is just shifted, that's it. Just it will be shifted, that's it. Yes, you can understand like this. What are the range of voltages possible for n? -2 to 2. And if I am adding -1 volts to this, -1 volts to this, then what are the range of voltages possible for y? So yes, -1. The range of voltages possible for n is -2 to 2, and I'm adding -1 volts to this n. Then what are the range of voltages possible for y? Will be -3 to 1, you can understand. Okay, so this is -3 to 1. Is the height, of course, is 1/4. Similarly, if you see the density function of y, when plus 1 is transmitted from the source, plus 1 volt transmitted from the source. Yes. It's the same thing. The range of voltages possible for n is minus 2 to 2, and I'm adding 1 volt to this n. Then what are the range of voltages possible for y will be? I'm adding plus 1 volt. Then what are the range of voltages possible for y will be minus 1 to 3, you can understand. Yes. Minus 1 to 3. Yes, the height will be 1 by 4. Yes. To the density function of y when plus 1 volt is transmitted from the source. Now, yes, by using this map theorem, this is actually the map theorem here, I can mention. This is the map theorem to find optimum V threshold. Now, as I said, for which y value this equality holds good, okay, or I can say both the density functions intersect with each other, that y value will be optimum V threshold. So to see the intersection between these two density functions, we have to draw both density functions in a single plot. Okay, yes. Now, so दोनों density functions को एक ही साथ plot करना है. Okay, yes. Yes, this fy upon minus 1, I have to multiply with p minus 1. P minus 1, it is 2 by 10 only. I can write. This is 8 by 10, 8 upon 10. So now you have to multiply this with fy by minus 1. You have to multiply with p minus 1. P minus 1 means 2 upon 10. So this will be, you will get 2 by 40, you will get. Yes. So I'm plotting here. So minus 3 to 1. Minus 3 to 1. This is. So this value you will get 2 by 40. You will get. Yes, no? So this what I plotted here. This is P minus 1. Fy by minus 1. This is. Similarly, you have to plot P plus 1 Fy upon plus 1. What is the probability of 1 volt to be transmitted? 8 upon 10, 8 by 10. And you have to multiply this density function with 8 upon 10. So that will be 8 by 40 you will get. This is minus 1 to 3. Yes, this is. So with proper scaling, we have to plot minus 1 to 3. This height is 8 by 40. Of course, 8 by 40 value will be higher than 2 by 40. And this, what I plotted is, this is P plus 1 Fy upon plus 1. Now, for which y value both density functions intersect, giving same value means intersection only. Giving same value means intersection only. So, for which y value both density functions intersect here? Minus 1. Okay. So, this you can understand as optimum V threshold. Okay. So, in the same question, if at all is asking to find optimum V threshold, your answer should be minus 1. Okay, fine. So, we got optimum V threshold. And with this optimum V threshold, we have to find probability of error. And that probability of error will be definitely minimum probability of error for us. Okay. So, continuing here. Yes. Yes, we have to find minimum probability of error. We have to find out. Yes, if you find probability of error with this optimum V threshold, then of course that will be minimum probability of error to us. So how to find the probability of error? So what is the probability of minus 1 transmitted? And what is the probability of error when minus 1 transmitted? And what is the probability of plus 1 to be transmitted from the source? And when that plus 1 volt is transmitted, what is the probability of error to occur? So P minus 1, PE minus 1 plus P plus 1, PE plus 1. Okay, like if you take a binary system like where 0 and 1 transmitted, then what will be the probability of error? Okay, that is P1 P0 by 1 plus P0 into P1 by 0. Maybe you're very comfortable with this, like for a binary system where 0, 1 and 0 and 1 transmitted from the source, then probability of error formula will be this P1 P0 by 1 plus P0 P1 by 0. Okay, or you can write like this also. This is P1. So probability of transmitted one received as 0 means it is probability of error only. Transmitted one decoded as 0 means that is error only. It is probability of error when 1 transmitted, PE1 plus. I can write this is P0 and this is the probability of error when 0 transmitted, PE0. So P1 PE1 plus P0 PE0, where 1 and 0 transmitted from the source for a binary system. Here minus 1 and plus 1 transmitted, then I can write probability of error is P minus 1 PE minus 1 plus P plus 1 PE plus 1, like that. Okay, fine. Now let's find PE minus 1. What is the probability of error when minus 1 transmitted from the source? Okay. Now, how to find probability from density function area integration? So it is when minus 1 transmitted or plus 1 transmitted, minus 1 transmitted. So here, what is the density function of y when minus 1 transmitted? Okay. Now here, so what is the probability of error when minus 1 transmitted means indirectly what is the probability of transmitted minus 1 is decoded as plus 1 at the receiver side. Okay, to be decoded as plus 1, y should be greater than theta or y should be greater than v threshold. Okay, this is. So how you can understand this is when minus 1 transmitted from the source, what is the probability of y greater than v threshold? Y greater than v threshold means that is decoded as plus 1 only. Indirectly, what is the probability of transmitted minus 1 decoded as plus 1 at the receiver side? That is nothing but what is the probability of error when minus 1 transmitted. Yes, v threshold is given how much? V threshold, how much you got? V threshold minus 1 is what we got. Okay, yes. So it will be. Yes, this is the density function we have, fy by minus 1. You have to find the area under this density function from minus 1 to infinite. Minus 1 to infinite means this. You have to find this area. This is. It takes the values up to 1 only. What is this area will be? 2 times to 1 by 4. That is 1 by 2. This is. Yes. What is the probability of error when plus 1 transmitted from the source? How to find probability from density function area? This is. Yes, it is when plus 1 transmitted. So fy upon plus 1. It is a density function of y when plus 1 transmitted from the source. Okay. So what is the probability of error when plus 1 transmitted means it is indirectly what is the probability of transmitted plus 1 decoded as minus 1 at the receiver side. Yes, to be decoded as minus 1, y should be less than theta. Theta means v threshold only. So y should be less than v threshold. Minus infinite to v threshold. Okay. So how you can understand this is when plus 1 transmitted from the source. What is the probability of y less than v threshold is what I am finding. Okay. Y less than v threshold means that is decoded as minus 1 only. Yes. So what is the area under this density function fy upon plus 1? Okay, from minus infinite to v threshold. V threshold is minus 1 only. Okay. So when plus 1 transmitted, what are the chances of y less than this v threshold? This is v threshold. What are the chances of y less than v threshold? Of course, there will be no chances. Okay. there will be no chances for y less than v threshold. Plus 1 transmitted. So I can say this will be 0 here. Then what is the probability of error? P minus 1 is of course 0.2 into Pe minus 1. Pe minus 1 is 1 by 2 plus P plus 1 is 0.8 is given in the question. Pe plus 1 is given as, how much you got is 0. So this will be 0.1 you got. And this probability of error we got, it is of course minimum probability of error only. Minimum probability of error. Why I'm saying this is minimum probability of error? Because we computed this probability of error with optimum v threshold. So definitely this probability of error will be minimum probability of error. Okay. Yes, this is the answer. And you can do this question, okay, in method 2 also. This is, and this will be a shortcut for you. Method. Yes. So minimum probability of error will be equals to, okay, so it is a shortcut for you. Okay, so what I done now, that is a conventional method. Now the shortcut for this is, it is, okay, area under common portion. It is simply equals to area under common portion of P minus 1 Fy upon minus 1 and P plus 1 Fy upon plus 1. Okay, yes, it will be simply equals to area under common portion of P minus 1. This is P minus 1 Fy upon minus 1 and P plus 1 Fy upon plus 1. It will be. So what is the common portion here? Between these two density functions, okay, what is the common portion? This is the common portion here. Simply you have to find the area under this common portion. What is the area under common portion here? This is simply a rectangle. The width is 2. The height is 2 upon 40. Means 1 by 20. This is. The height is 1 by 20. So this will be 2 times. The height is 1 by 20. So this will be 0.1 only. So this will be the shortcut. So in gate examination point of view, in objective examination point of view, definitely I suggest to go for this shortcut. Okay, so within no time you can get the answer. Yeah.